one, the filtering of the long duration sequences. If one of my signal x of n is a long duration sequence compared to my h of n, h of n is both are finite duration, but at the same time here, if my signal x of n is a long duration sequence, then I can go for sectioned convolution. Because if I want to store my intermediate result, then I will have a lot of amount of memory, right? So in order to avoid that, we are going for section convolution, or we can call it as a filtering procedure. So here, because of the length of x of n, it is not practical to store all before performing the convolution, and hence the input sequence must be divided into blocks. So the long duration input sequence x of n is divided into blocks. We have to mention the block size while doing our procedure, right? So while writing our overlap method or overlap save method or overlap add method, in both the procedures we have to mention the block size first of all, and then depending upon the our block size, we have to divide our input signal, long duration input signal, into blocks, and then we have to do for our convolution separately one at a time, and then finally the results are combined to get the final result, that is the filtered result, convoluted result, right? So in this case, we are doing with two kind of procedures: overlap save method and overlap add method. So with these two procedures, we can do our convolution procedure. So either with the overlap save method or overlap add method if you are doing, but the final answer will be the same. So you should remember that, right? And also, if possible, you can do the linear convolution, or if possible you can do the circular convolution, right? So if you are doing with that, then the answer, if you are doing with the linear convolution or overlap save method or overlap add method, the answer is same for a set of inputs x of n and h of n. You should remember that, right? And